So here we're dealing with equations that contain radicals with variables in that radicand. So do we have to have a radical sign in radical equations? Absolutely. And what has to be in the radicand? A variable. Okay, we're going to start with the simple ones today. All right, let's look at example 1 and see how we're going to deal with this. So page 732, example 1a. They give me the square root of x plus 4 equals 7. All right, my very, very first step on these problems is to get the radical by itself. Isolate the radical. Okay, what normally do I want to get by itself on other equations? I want to get the variable. But I'm saying I want to get this radical by itself, and then I can get the variable by itself. So I'm going to push that to the second step of getting x by itself. I want to just get my radical by itself right now. Does anyone know maybe what you could do? How do I get that radical, the square root of x, by itself?
Subtract 4.
Yep, subtract 4. So normal procedures to get rid of numbers that we don't want on one side. I'm left with the square root of x equals 3. Okay, is our radical isolated? Is it isolated by itself on one side? Okay. Does anyone remember now how to get rid of this radical sign? How do I undo square rooting? I square it. I'm going to square this right here. That will undo the square rooting. But what I do to one side, got to do to the other. I got to do it to both sides. I can't just do it to one side because I'll make an imbalance. But if I do it to both sides, I might make a balance. Do you hear that word? I didn't say you will make a balance. I said you might make a balance. Interesting. Okay. Does anyone know what the square root of x squared is? X. So drop that sign, drop that squaring. And then what's 3 squared? 9. Okay, I'm going to circle this, but I'm not sure that's my answer. Okay, when you work out equations with radicals, sometimes this happens. When you square both sides of an equation, or cube, or fourth root, or raise them to the 4th power, you might get an answer that's wrong. You might get an answer that's wrong. So do you guys remember when I'm working out an equation in the past, there's a way you could be certain that that's the answer. What do? Yeah, so what do we call that process? You check. You check your answer. So I'm gonna go here. I'm gonna put 9 for x, and this is my check. On your homework, you will check your answers, and you're gonna be like, man, I don't like checking. Well, normally your check works with what your answer is, but you're gonna find out today that doesn't always happen. That check does not always work. And then what do we do? Well, we'll find out in just a moment. All right, what's the square root of 9? 3 plus 4 equals 7. Is that true? So is x really equal to 9? Yes. This is my answer. It checks. Okay? So is that good? We're fine with that one? Let's go to B. If there aren't any questions here. Okay? And if you do, just raise your hand. We'll go back to it. Or maybe you have it on B. Okay, on B, the square root of x plus 3 plus 5 equals 9. All right, what's my first step on these problems? To isolate the radical. Isolate that radical. And how do I do that on this problem? How do I isolate the radical on this problem? Lucy?
First point, you have to combine the 3.
Sorry, say it again. I was clear.
Would you combine the 3 and the 5 and then subtract 8?
Okay, so maybe you're thinking, can I combine these two? Now that I think of it, this 3 right here is kind of stuck in that radical sign. I can't take it out. I can't mess with either one of these until I get rid of that. There you go. I'm just going to subtract 5 from both sides. 5 is free to go, and he does, or she does. And we get the square root of x plus 3 equals 4. Okay, did we isolate the radical? Is the radical isolated? Yes. What do we do to undo the square rooting?
Square it.
Square it. Good. So you square both sides. Good. Both sides. Got to keep it balanced. Is it possible when I squared both sides that I get a wrong answer? The answer to that question is yes. So I'm going to do this process, see what happens. What's left here on the left? Yeah, it's just x plus 3. The radical sign went away and so that squaring because they undid each other. And what's 4 squared? 16. And now you have your normal, simple, hopefully, equation. We'll subtract our 3. We get x equals 13. I'll circle that for now. For now, I will circle it. Okay, so what do I do to make sure this is my answer? And I will be looking for your check. It's part of your homework to check these. Yes, ma'am. Yeah, I got to put it in there as the original equation. 13 plus 3 plus 5 equals 9. All right. What's 13 plus 3? What's the square root of 16? Is 4 plus 5 equal to 9? It works. Check. That's the right answer. Carrick?
Could you check if I just put in 13x on after you square?
Right here?
Yes, sir.
I mean, you could, but what happens is if you messed up from here to here, then even if this checks in this spot, it might still be the wrong answer. Always check an answer with the original problem. Because you may have maybe you added 5, and you did all this right after doing that. You get a good answer that fits this, but when it gets back to the original, it didn't work. So that's a good question. All right. How many of you, I get what to do. First step is what? Isolate the radical. Good, I heard it. Then you isolate the variable, okay? Because you got to get rid of that radical sign. Page 734. 734, I'll have you guys try out number 6. Which deals with the square root of x equals 6. This is a simple equation. What's your first step? Isolate the radical. What do you notice about this problem? It's already isolated. So you go to your next step. I want to get rid of this radical sign. Does anyone remember how to do it? Alex, you remember how to do it? Square it. Square both sides. And you work out the rest. And you check it. And yes, it's a simple equation, but check it. Do you have a question or answer? Question, go ahead.
So, on this problem, can we just check it in our head?
Hold on. What was the question?
Can we check it in our head?
No. I'll give you 2 things here. This one you can, right? Can't most of you check in your head? You're not going to get these on your homework. These are too easy. So is that kind of answer? Some of them like this, if you had this on your homework, I guess you could check in your head. But you're not going to get this. Okay, but who has an answer for x? I want x. X equals, yeah, Maggie? 36. Are you sure about that? Okay, the square root of 36 is equal to 6. Is that true? Okay, it works. Great. Yes, sir.
What if you mess up on the check?
Yeah, if you mess up on your check, that forces you to go back to the original problem. I look at it, did I do everything right? And I really like seeing this when I come ask you a question, or you ask a question, I come to you, and I'm like, is that right? And you're looking at yourself, so then it makes you evaluate, wait, that is it. Then you redo the check. You mess up on the check, you can. And then you go back to the original, recheck. Okay, number 7. Go ahead and do that one on your own. And yes, check on the paper. I'm checking your paper for work on number 7. All right, what did you get for A at the end? Sorry, I'm going to call on someone. Rosalind, what did you get for A? A equals 1. All right, I'll circle that. How did she get to A equals 1, Brian? How'd she get there? Okay, isolate. Squared. What'd she get left with? Then what'd she do? Oh, we match up. And does it work in the check? Is that true? Okay, so it works. How many of you got A equals 1? Good, good. All right, so you get at least you get the basic process, right? Isolate the radical. How do you get rid of a radical? Like square root. You square it. And then you solve for x. You know what I just noticed, guys? Remember how I said sometimes your answers are wrong? All of our problems have been right when we check them, right? Hasn't it been all of them check out? Example 2. Three x minus 5 equals x minus 5. All right. First step, Jackson.
Isolate the thingy.
The
Radical.
Good, the radical. And that's already done. So Autumn, what do I do next? Square both sides. So I'm going to square this left side, and squaring the right means I do this. I square the entire right. So x minus 5 squared. That's a binomial. I have to square it. Okay, what's left on the left side, Lily Mooney? On the left. 3x minus 5. Great. Uh-oh, right side. What do I do with that? Does anyone know what x minus 5 squared means in just multiplication terms? It means x minus 5 times x minus 5. So what do you use to figure that out? Yes, FOIL. And some of you are getting really good at FOIL. But using FOIL yields that. How did I get that? Well, again, it's x minus 5 times x minus 5. And what happens is you get that x squared, and then you get negative 5x and negative 5x, negative 10x, positive 25. So that's FOIL. Have you ever had a problem that has this in its work? Have you ever had this? Have you ever taken a test here? That's the question I'm asking. You've done this before. Now, on these problems where you have a squared term, you really want to get everything to one side and get what on the other? You guys remember what I want to do? Get everything to one side and get 0 on the other. So normally I say to go left, but you don't have to go all to the left. You can send it all to the right. So I'm going to get rid of the 3x by subtracting 3x. How do I get rid of that negative 5? Add 5 to both sides. And I am left with what on the left side? 0. Good. Not nothing. 0. 0 is not nothing. It's something. It's not a lot. Yes, ma'am? Because I want one side to be 0, which I wanted the left side to be 0, and then the right side to have everything else. So you could have moved everything to the left, but then you have negatives at. Oh, I see. That's if you have just an x, but if you have an x squared, now you want to send everything to one side. All right, this is what I get. X squared minus 13x plus 30 equals 0. That's helpful. You know what to do with this? Abby, do you know what I could do here?
Simplify the thing on the papers on the right.
Okay, what do you mean by simplify? Oh, I heard whispers of it. It's a special word we've been using now for a while. What's that special word? Okay, good, because you're going to factor it, right? Factor it into two binomials. You're going to get x and x. And what fits in those spots? Yep, Jenna? -3 and -10. -3 times -10 is positive 30. And -3 plus -10 is -13. So that works. And it still equals 0. And great. Thank you for the factoring. What do I do with this now? Turner, do you know what to do?
You'll set it up so like x minus 3
Okay. Oh, yeah. Because when you have two things being multiplied and they equal 0, what does one or both of them have to be? They have to be 0. So you set them up. And you get x equals what? No, not all at once, please. Somebody help me. So, 3 and 10. Good. Positive 3 and positive 10. Yay, we got it. Or did we? What a great question. All right, you leave the problem here. You're going to be sorely disappointed because we didn't do this. We didn't check it. Okay. I need some help. Nate, can you give me the original problem?
Yes. So the square root of 3x minus 5 equals x minus 5.
All right, what I'm going to do is I'm going to check it twice, once with 10, once with 3. All right, 10. So I'm going to have here 3 times 10 minus 5 equals 10 minus 5. All right, what's 3 times 10?
30.
Yep, 30 minus 5? 25. And that's 5. Is this true?
Yeah.
Oh, duh, because x equals 10. We're okay with that, right? We checked it, 10 works. Mr. A, we're just checking for no reason. This is pointless. Takes up a lot of space. You know how many trees had to be cut down? No. You know how much graphite had to be formed? You know how much, what's the eraser made out of? Rubber, okay, synthetic rubber. You know how much rubber had to be? However you make rubber? No. Okay, what's 3 times 3? 9 minus 5? Okay, the square root of 4 equals... Is that true?
No.
It's false. You know what else is false? That is not true. It's not 3. It's 10. Why? That's a deep question. That's like a philosophical question. Why doesn't 3 work? Numbers are ideas. The symbols we use to represent those ideas are here, but they're also here. But they're there. Where am I going? I forgot. What's your question again? This is the reason why it doesn't work. When you squared both sides, you introduce the possibility of getting a wrong answer when you square both sides. And that's because of the positive negative. How many square roots does a number have? Think of 25. How many square roots does it have? It has 2. What's the square root of 25? -5 and +5. Okay? So you have 2 possibilities. Not always are they both correct in the problem. So when you square things, you undid that, and you actually introduce a wrong answer, possibly. Does it always happen? No, don't think they're all going to be no solution. All right, but here, yes, Maggie, question? Oh.
Why is -2 work? Because -2 is 4.
Oh, great question. This symbol right here is a square root symbol, and it's asking for the principal square root, or the positive square root of 4. So, yeah. Good question. Yep, that's it. Can I give you, that question brings up a big memory. And actually this reminds me of what I talked to them about. I remember my second year teaching, I was teaching Algebra 2, and somebody asked me that same question. And, it's with 10th graders, and I'm standing up here, second year teacher, so still not like super confident at all, and still kind of shaky. Square root of 4 equals -2, and then I was like, all right, that doesn't equal, and I keep moving on. Don't record this Swivl. Pause Swivl. Has this happened before?
I put it on the notes, I promise, and I don't know how it.
So what I'll recommend, so it doesn't happen, is just put it in your locker. Don't leave it in your backpack if it's going to do that again. Okay, but anyway, they asked me this question, and they're like, hey, isn't -2 times -2 4? I was like, yeah. So why isn't -2 the answer? They could see right through me. And I don't know what I did, but I was very caught off guard. You know what that helped me to do? That helped me to understand what I am trying to do in this class. So Maggie, if you would have asked me 5 years ago, what a great question, Maggie. That would have been my response. Swivl would have caught it, would have gone on the internet. I would have never recorded another video again. I had to understand, why is it not -2? Well, I had to look this up. I had to look up, what does that symbol mean? Because there are 2 square roots of 4. But when you use this symbol right here, you're using the principal square root, which is the positive square root. So you learn through experience. So do you guys know what the square root symbol means? It's looking for the positive square root or the principal square root. Good, good. Okay. Great questions here. They're such great questions, great answers. I'm going to go ahead and give you your homework. Your homework was going to be like the odds. You know how I give you your odds. Then I worked them out, and by the time I got to like number 25 was good. 27, like here's my work on 27. And then 29. And then I turned the page because I did more. This is one problem each. And thank you. Actually, I do this. I'm enjoying, like, yay, we get to do math. Okay, but I did the work and I was like, man, that's going to be kind of tough. So I had to reevaluate, look at the problems. So I did the problems a little differently. Today, your homework is going to be, and this is due when? Wow. You can bring it to me tomorrow, but I won't do anything with it. 18 to 28, all 735. And I put this in my notes. Check your solutions. Exclamation point. Please check. If you don't check, it won't be good. Yeah, check them all. Yeah, do 18 and 28 all. Check them all. If you have a retest, when is that due? Monday. If you are in my class, you also have homework due on Monday. So don't wait till Sunday night. You may be able to get through it, but you might not do your best, and that's not going to be good, especially for that retake, which I'm trying to help you out with, giving you many days to do it. What else was I going to say? I think we're good. Ask questions, and I'll try to help you out as we have time.